All right, so we left off with the last question. There was someone in my class. We're recording. There was someone in my class who asked, "Are we this?" I said that if we were, I would want a greater growth rate. But they were like, "Do you really want to turn the world into zombies?" So it depends on which side you are on. If you're on the side of wanting to live as a normal person, then you're right. You wouldn't want a greater growth rate. But if you are on the evil, sinister side, if you are evil, then you are going to be able to get more zombies by having a greater growth rate. The growth rate is really what moves us faster and faster. If we go to our antidote and we have found an antidote for our zombies, and we're assuming that everybody except for, we had the conversation about, does a zombie come up with the antidote? But no, we're just going to say there's one soul living left underground and they come up with the antidote. So 15%, we're starting with 100%, and then we are going to subtract 15%. So each time we are actually going to have 85% left as zombies. So if I go to 6,975,000,000 and I multiply by 0.85, did anybody else get 5, 9, 2, 8, 7, 5, and then 4 zeros?
3.
I got 4. And then if I multiply by 0.85, I get 5, 0, 3, 9, 4, 3, 7, 5, 0, 0. And then if I multiply by 0.8, each time I'm multiplying by 0.85 because I want 85%. This is times 0.85 times 0.85. 4283521,875. One of my students, we don't have any half of zombies. We're still at 36409935594. Wow, these are big numbers. Lots of people. 309. It doesn't seem like we're making a lot of 4, 5, 5, 5. It seems like we're going slow. Now we're at 26306178771. Now I'm at 223602519. 1900621412, and I keep trucking. 16155282200. Woo! 137319890. That is huge. That is a lot of zombies. But if we want to write an equation, our exponential equation is still going to be the same. Our starting point is the 6,975,000,000. And then we're going to multiply, but instead of multiplying by 3, what did I multiply by every single time? 0.85. So this is going to be my equation. If you don't have the equation written down, you may want to add that to your notes. This would be my equation. each time, how many of you continued on to find out how many days it would take for the antidote to work? 10 days, we still got a heck of a lot of people. What if you said 6, 9, 7, 5, 1, 2, 3, 1, 2, 3, 0.85? I'm going to try 20 days. Not enough. I'm going to try 40 days. $60 days? Why is it taking so much longer? Because it's only losing 15. Think about the difference between 300% growth and 15% decrease. It says, what pattern of decay do you notice in the number of zombies? We know that it's going down, right? If we kept the pattern, I'm just giving us a sketch because we're running out of time. We're going to start seeing it to level off. And just like it's exponential to growth, if you graph this, you would have something that looks like this. At this rate, how long will it take scientists to completely turn all of the zombies back into humans?
More than 100 days.
Okay. More than 100 days. More than 100 days. Would you ever get every single zombie?
No, because if you wait 100 days, like you have to be able to survive that long.
Well, I'm looking. What, Kobe? This goes into your decimals of people. Really, does that number ever turn into 0? No, because if you have one zombie left, there's going to be 85%. That's still, and then 85%, and then it's still never going to completely go away. What similarities? Is there anything similar? Well, I was nice to you. I already gave you the similar, right? We're always going to be in the form of where we start. A is where we start, and B to the X. This is our growth rate or decay rate. Growth or decay rate. So that changes, but the A is always where we start. It's snowing. It's not snowing. It's cloudy. Yeah, we're not done. We're not done. What number? Guys, please stop. You are in 11th grade. It's all right. It's a cloud. It's called fog. We've all been there. What number in the equation impacts whether or not the initial value will increase or decrease over time? We've already talked about that. Not the X, it's what's being raised to the power of X. It's the B. Canadian mathematicians and authors of When Zombies Attack, Mathematical Modeling, published a Journal of Infectious Disease Modeling Research. And they concluded that the secret to our survival is to hit zombies with everything we have, hard, fast, and early.
Oh, yeah.
Do you all agree with that? What's the most, well, hard, fast, and early? Which one do you think is, which variable would be better?
Early.
Fast.
Oh.
Or fast early, kind of the same, right? The earlier you get to them, the better. The earlier you get to them. All right, you guys are going to have a few